Okay, here's your Unit 3 study guide. For number 1, we're going to match the ordered pairs that work for the following equations. Be sure to show your work. Okay, so first of all, I'm going to look at my ordered pairs, and I know that the first digit is an X and the second digit is a Y. And what I'm going to do is decide which of these ordered pairs I think would be true for each equation. So I'm just going to get started here with substituting in a 3 where I see an X and the 4 where I see a Y in my first equation to see what happens and to show you how this works. All right, so now I'm going to sub in a 3. Okay, now you go ahead and you solve. Does 4 equal 2 times 3, which is 6, and 6 plus 3, which equals 9? Well, no, of course not. So this first ordered pair is not a solution for the first equation. Now I'm going to look at my other ordered pairs and see, well, what else could I try? Should I just keep going? But I'm kind of eyeing up this one over here because I see a 0 and a 3, and I see we have a 3 in our equation. So let's see what that one looks like. For the Y value, I'm going to sub in a 3, and I'm going to do 2 times 0 plus 3. Well, I think this one's going to work because 2 times 0 is 0, and 0 plus 3 is 3. So this one does work. So the ordered pair of 0, 3 works for equation number 1. Okay, moving on. Let's see, so I'm going to look at my ordered pairs and I'm going to see, well, maybe I'll go back and try this one into this equation. Okay, so for the X value, I'm going to sub in a 3, and for the Y value, I'm going to sub in a 4. And I think this one's going to work because 2 times 3 is 6, and 6 plus 4 is 10. So that checks out. So the ordered pair 3 and 4 works for the second equation. Okay, so now I have 2 ordered pairs left. Let's see, I'm kind of eyeing up this one for over here. Let's see if this one works. Okay, the Y value is -6. The X value is -5. -6 equals -5 minus 1 is also -6. So this ordered pair is a solution, or it works for this equation. That must mean that my last ordered pair here would work in this last equation. Let's try it because we have to show our work. So 4 times -1 plus 5 times 2, does this all equal 6? Well, 4 times -1 is -4, and 5 times 2, remember I'm following the order of operations, 5 times 2 is 10. Does that equal 6? It sure does, because -4 plus 10 does equal 6. So the ordered pair of 1, 2 works for that equation. For number 2, we're going to find the slope of each line and write an equation in y equals mx plus b form. Okay, so noticing my first graph here has a horizontal line. We learned that a horizontal line has a 0 slope or no slope. So to write the equation of a horizontal line, all I have to do is eye up where it crosses the y-axis. That's our intercept right there. So on the y, it crosses at -2. And that's it. That's my equation. For graph number 2, we learned that a vertical line is undefined. So we have an undefined slope. And to write an equation here, I notice that on the x-axis, it crosses at +2. So that's all I have to do to write my equation is say x is 2. Okay, the next example, we have a positive slope. I can tell this because the line is increasing when I read it from left to right. So to find the slope, I need good points. Well, here's a good point, and it appears that this would be a good point as well. I'm going to make a right triangle to get our slope. It rises 1 block, and it runs 1, 2, 3, 4, 5. So my slope is a +1/5, rise over run. Also, in the equation, I need the b. That's the vertical intercept or the y-intercept, the place where it crosses on the y-axis. This one crosses at a +1. So my b is a +1. Now I just put both those things into my equation. Y equals 1/5 x plus 1. For our next example, I can tell that it's going to be a negative slope because when I look at it from left to right, it's decreasing. So I know the slope will be negative. So I still have to find my good points. Anywhere on the line, find 2 consecutive good points and draw a right triangle, rise over run. Looks like it rises 1 and runs 2. So my slope, my b, is -1/2, or my m, I'm sorry. My b is the intercept where it crosses the y-axis. This one crosses at 3. Now to write the equation, I just fill in those 2 spots. I fill in the slope where the m is and the intercept where the b is. So this is -1/2 x plus 3. Okay, for the next one, I have to describe a situation that goes along with this graph and write the equation. So let's look at the graph first. We know it's gasoline usage and it's gallons in the tank. So knowing, because I drive, I mean, I'm sure you guys have been on road trips or something. You start with a certain amount of gas in your car, and the more you travel, the gas will decrease in your tank. So you would write a little situation about, going on a road trip and the gas in your tank decreasing. And then to write the equation, we find the slope and we find the intercept. Well, I can see the intercept right away is 15. The slope, I'm going to have to find good points and draw my right triangle. Okay, so I see here's a good point, and I'll go with this one. This looks like a good point right here. Okay, rise and run. Looks like it's rising 1 and running 2, and it's negative. So my slope is -1/2. It doesn't tell us what the x-axis is. I'm assuming that's something to do with distance traveled. So maybe every mile or so, it's decreasing in gas. So my equation would be y equals -1/2 x plus 15. And then we have to describe the situation. Something like you leave your house with 15 gallons of gas, and as you drive, the gas is decreasing a half every mile or something. Okay, so something like that. You leave home with 15 gallons of gas, and as you travel, the gas decreases. For number 4, it says find the slope of each line. Which graph is the steepest and how did you determine this? Okay, so the graph's a little fuzzy. I'm going to be zooming in a little bit here. Remember, to find the slope, we have to find good points and then make the slope triangle and count the rise over the run. Okay, so it looks like maybe right here is a good point on the graph, and then maybe right here. Okay, so then I draw the slope triangle, rise over run, and it rises 1, 2, 3, 4, 5, and runs 1. So graph A, the slope is 5 over 1, which is also the same thing as just 5. Moving on to graph B, let's find good points. Okay, as I'm looking, I think I like right here as a good point. And possibly here is a good point. It's just kind of fuzzy. All right, let's go with those two. So we're gonna rise and run. 1, 2, 3, 4, rise 4, run 2. So for graph B, 4 over 2, which is a slope of 2, because 4 divided by 2 is 2. All right, let's check out graph C. Let's see. Maybe every point is a good point. That looks pretty good. That looks pretty good. Okay, these ones look pretty good, so I'm going to make a triangle between any two. It rises 1 and runs 1. So graph C is 1 over 1, which is the same thing as just 1. Okay, and then graph D, let's find our good points there. This one looks pretty good. Maybe this one, this one. Okay, so we're gonna go rise and run. Looks like it rises 1 and runs 2. And so our slope is a half. Okay, so now we can answer the question, which graph is the steepest? That would be the largest number, the biggest number. So the steepest is graph A, and how do we determine this? Because it has the greatest slope. So let's go ahead and answer that. We would say graph A is the steepest because it has the largest slope. Okay, next we're going to examine tables, equations, and graphs. So just so you're aware, here we have Sarah, and she has a table of cupcakes. We have Kara, which you can get the cupcakes cost with an equation. And then we have Ken, who has this graph right here. Okay, so there's a hint here that says we're going to find the cost of one cupcake for each company. All right, so let's start with Sarah. So Sarah, it tells us that it's $1.50 per cupcake. Okay, because I got that right there. When I look at Kara, we have an equation, and it tells us the 2, that's our slope, which is also known as the rate. So that means it's $2 for each cupcake. So hers is $2 per cupcake. And then when I look at Ken, his, it looks like for 2 cupcakes, it's $5 right there. So if it's $5 for 2, that would mean it's $2.50 for 1 cupcake. Okay, so now we can answer the question. Which company has the cheapest cupcake? You could see it's Sarah. And how did we determine that? We found what's called the unit rate, or the rate per cupcake for each one. Okay, so I wrote my answer that it's Sarah. It costs $1.50 for one compared to the $2 or the $2.50 for the other places. I used the unit rate to figure this out, to determine this. Okay, remember the unit rate is like the rate, which is like the slope. In question 6, a truck is shipping jugs of drinking water and cases of paper towels. A jug of drinking water weighs 40 pounds, and a case of paper towels weighs 16 pounds. A truck can carry 2,000 pounds of cargo altogether. Write an equation to represent the situation. Okay, so we know the total that a truck can carry is 2,000 pounds. So let's figure out what our variables could be first. How about we use X and Y? We'll use X for the water, the jugs of water, and we can use Y for the paper towels. Okay, so the X value is 40 pounds for each jug. So that is 40X. And the Y value is 16 pounds for each case of paper towels. So we add those together, the total cannot exceed 2,000 pounds. Next, we're going to see how many cases of paper towels if we already have 10 jugs of drinking water. So we said our jugs of drinking water is going to be the X value. So 40, and in place of the X value, we have 10 jugs of water plus 16Y equals 2,000 pounds. Okay, so let's go ahead and do 40 times 10, which is 400, plus 16Y equals 2,000 pounds. Okay, so now this should kind of take you back to last year where we solved for a variable using inverse operations. I'm going to subtract 400 on both sides. And that gives me 1,600. So 16Y equals 1,600. And then our last step would be to divide by 16. So our Y value would equal 100. Okay, so what that means for water, if we have 10 cases of water, that would, you could do 100 paper towels. Next, we have to find two other combinations that would total 2,000 pounds. So since we already did 10 jugs of water, I'm thinking maybe it would be easiest just to double that and do 20 cases of water. So let's put that into our original equation up here. So we're going to do 40 times 20 plus 16Y equals 2,000. So this is going to be 800 plus 16Y equals 2,000. Subtract 800 on both sides. Okay, so 16Y equals 1,200. And then our last step would be to divide by 16 to see what Y equals. And that equals 75. Okay, so 20 jugs of water holds, and then we could have 75 cases of paper towels. All right, we have to find 2 more combinations. So since we did 10 and 20, let's go ahead and do 30 and see if there's a little pattern there, because I'm noticing something here. Okay, so I'm going to go ahead and do 30. So back to my original equation. So 40 times 30 plus 16y equals 2,000. It's probably going to be 50, so I'm looking at the pattern here. That's going to be 1,200 plus 16y equals 2,000. Subtract 1,200 on both sides. So 16y equals 800. And then 800 divided by 6. And yep, that equals 50. Okay, so that pattern did continue. Okay, now you could do other amounts. We could do lesser amounts and have less water and more paper towels, and we could keep going. We could extend this table and keep going that way. Okay, the big thing here is, can you take a situation, write an equation, and then use that equation? Okay, number 7, a gym membership is $100 to start, and there's a $40 charge each month. Okay, so to start, that is signaling me that that would be the intercept or the beginning, and there's $40 each month. That would be our rate or a slope. What's the total cost? The startup fee and the monthly charge. So the startup fee and the monthly charge for 1 month would be $140. Okay, next it says, what's the total cost for X months? That's where we're going to write our equation. Y equals mx plus b. So y equals the rate, which is $40, x, and then the startup or the initial value is 100. So that's our equation. Just use y equals mx plus b to figure that out. Now we're going to graph the cost of the gym membership over a period of 18 months. So I need my x-axis to be the months, and the cost is going to be the y-axis. Be sure to label your axes and scale them by labeling each grid line. So I have to go to 18 months, and I don't think I could fit 18 here, so I'm just going to skip count by 2s for that. So 2, 4, 6, 8. And then to figure out how to scale my cost, I'm going to use my equation for 18 months and figure out what's the max I need on here. So I'm going to do y equals 40 times 18 plus 100 to figure out what that equals. So 40 times 18 plus 100, that is going to get me to 820. So all that is 820. So I want my y-axis to go all the way to 820. So I'm probably just going to go by hundreds, and then I'll have to do some estimating here. So go ahead and skip count by 100. Okay, so now I have to figure out what all my points are. So I'm thinking about maybe using a table of kind of like an X and a Y table over here. So we know 1 month is 140, and we know that we need a few ordered pairs to plot, and we know that 18 months is 820. So I'm going to use my formula to figure out, or my equation to figure out the cost of 2 months, and then maybe I'll do 8 months, and I'll do 10 months and 16 months. So if I just use my equation, then I can figure out what points I want to plot. Okay, so I'm going to do all that. So let's do 40 times 2 plus 100. So that is going to be 40 times 2 is 80. Okay, so that's going to be 180 for 2 months. And, okay, let's do 40 times 8 months plus 100. So 40 times 8 plus 100. So that's 320 plus 100. So that is 420 for 8 months. Okay, so I'm just getting myself some ordered pairs here. Let's keep going. Let's do 10. 40 times 10 plus 100. So that's going to be 400 plus 100. That's 500. Okay, and that's probably enough points. Maybe just for the heck of it, I'll do the 40 times 16 plus 100 to see what that is. Okay, so that's 640 plus 100, so that is 740. All right. So now I have a collection of ordered pairs, so now I'm going to plot those as best as I can. I'm going to have to estimate because I don't have like a perfect graph here. All right, so over 2 up to 180, that'd be about here. Okay, so that'd be about there. And then over 8 up to 420, that'd be about there. Over 10 to 500 is right there. 16 and 740 is about there. And then 18 months would be about 820. Okay, so that looks pretty good, pretty in line. All right, then I'm going to connect those. Oh, and our initial value, our startup, was at 100. All right, so I'm going to connect those to there and answer the next question. Is there a proportional relationship? Ooh, or is it non-proportional? So you have to go back and remember it doesn't start at the origin, so it's non-proportional. And then you're going to have to explain why and say something like it doesn't go through the origin. Okay, so you have that part. And then for part E, you're going to draw a line that's parallel to it that goes through the point of 0, 160. Okay, so we're going to go through 0, 1. So we're going to start at 0, 160. So here. And then it would have to have the same slope because it's going to have the same membership rate. Okay, so that means it would go run parallel to this, but start at 160. Okay, so what would the initial fee be? So the initial fee would be 160. And then how much would it cost? It would be the same cost because it's parallel. Okay. Find the slope between 2 points. We know how to do these. We label xy, xy. I'm going to call this my first ordered pair since it's here first. And I'm going to call this my second ordered pair because it's their second. And then we fill in the slots. y2 minus y1, negative 14 minus negative 18, and then x2 minus x1. Okay, being careful with our double negatives, we know that double negatives can create a positive. Also be careful here, negative 14 plus 18 is 4, and negative 7 minus 12 is, or negative 7 minus 5 is negative 12, and this can simplify to negative 1/3. Moving on to the next example, same thing, label your ordered pairs, assign the 1s and the 2s, and then make sure you're filling in the correct spots. y2 minus y1, x2 minus x1. a double negative joins together to create a positive. So 13 plus 14 is 27, and 20 plus 11 is 31, and nothing, they have no common factors, so that's your final answer. Graph the following lines. So remember, y equals mx plus b. So in here, the m, or the slope, is 3/2, and the b, or the y-intercept, is 2. Begin at the b and plot a point. So we plot a point at 2, and then from there we rise and run. So from there, I'm going to rise 3 and run 2, and then put another point. And we're going to continue the pattern in the opposite direction. So down 3/2, put a point, down 3/2, and that's all the points I can fit. Then you neatly connect them, and there you have it. It has a positive slope of 3/2, and the intercept is 2. Okay, for this one, the m, or the slope, is a negative, so we know that our line has to decrease, go down, and our b, our intercept, is +1. So we begin at the b, which is +1, and now we apply the slope. The slope is negative, so we go down 1, forward 2, plot another point, and then repeat that pattern. Down 1/2, plot a point, down 1/2, plot a point, and we can reverse it. We can rise 1, go forward 2, rise 1, go forward 2, and fill up the graph. It's always good to have at least 5 points if you can. Then neatly connect, and you can see I have a negative slope. It's decreasing, and it crosses at 1 for the intercept.